Hello everyone, welcome to new question of our graph theory series. Today we are solving question number 54201 matrix. It is a breadth first search traversal technique. It is a problem of BFS. So we have given n cross m binary matrix mat. We have to return the distance of the nearest zero for each cell. The distance between two adjacent cell is 1. So like we have given n cross n matrix, we have to return the distance from each cell to the nearest 0. Like for this cell, it is 0. So the nearest value will be 0. For this cell, the value will be 0. This cell value will be 0. This cell value will be 0 because this is 0. So to grow from 0 to 0 is 0. Distance is 0. For this node, if you check the value is 1. So its nearest distance is 0 to 0 is can be this path or can be this path, can be this path or can be this path. It can travel in the all four directions. It can travel in four directions. So the nearest 0 is this or is can this. So nearest 0 distance will be 1 and for each 0 the distance will be 0. So one thing we have to keep in mind for 0 distance will be always 0. So this is our question. We have to return the two-dimensional list of the nearest distance. M equal to mat dot length, n equal to mat I dot length means column dot length. Mn will be 1 to 10 to the power 4. M into m will be 10 to the power 4. Value will be either 0 or 1. There are at least one 0 in a mat. We have at least given one 0, so we can go to the 0 from the ones. Like if example, if you check for this value, nearest 0 is 0. For this value, nearest 0 is 0. For this value, nearest 0 is 0. For this 0, nearest 0 is 0. But for this one, the nearest 0 is can be this, can be this, can be this, both having the distance of 1. So nearest 0 will be 1, both having the distance 1. For this one, the nearest 0 will be this because it has distance of 1. So for this, the value will be 1. For this node, its nearest 0 can be this node or this node. So if we go first 1, then 0. Otherwise, this path 1, 0, this path 1, 0. For all the cases, the value will be 2. This node, it has direct connection with 0, so value will be 1. So it is a pretty simple question we have to solve. Like let's walk through in this example and let's discuss the approach how we will solve this problem. So this is our problem. Let's solve this problem. So what we will gonna do, since you can check that from every zero we will find the distance to the one. Means what we will do, first we will create a queue. We will create a queue and we will insert all the zeros indices to this queue. Like this is index 0, 1, 2, 3, 4, 5. Sorry. Oh, I don't know what I'm doing this. 0, 1, and 2. So this will be our indices. So what we will do, for each 0, we will insert 3 values. For each 0, we will insert 3 values. First is its row 0, column 0, and it is distance to the next one, means distance from the 0. So its distance from the 0 is 1. For this node, 0, 1, sorry, 0, 0, and distance from the node is 0. For second one, 0, 1, and distance from the node is 0. For the third value, 0, 2, distance from the node is 0. For this value, 1, 0, distance from the node is 0. Then for this 0, 1 and 2, distance from the node is 0. So first value is row, second value is column, and this is the distance. So this is our queue. So here we will like how we will proceed. Like for in every iteration, this is our 0 value, this is values is 0. So from 0, if we move one direction, how many ones we can cover? Means for this we can, if move one direction, if we move one direction, how many one can we cover? We cannot cover any 0. For this we cover this. So we can cover, if we move one direction, we can cover this. We can cover this for one direction, one move. We can cover this by one move. So these values can we can cover by only one move. So this point is very important point. Means for every iteration, means we will check in each step how many ones we can cover. Like we can cover this. Now for value 2, this is covered, so this is now 0, means this is marked. And now from this how many values we can cover in second iteration? Means for first we can go there, for second we can go there. So in second we can cover this, so it will take 1 minute, it will take two distance. So this will be our approach. So what we will do, we will find its row, we will find its column, we will find its distance. So distance will be its current value, means if we, means if we denote the first of, sorry, if we denote the first value as current, then row will be current of 0, column will be current of 1, and distance will be current of 2. And initially we will set that for this value, means for mat row and column, our, means if we will remove this, we will create a distance, means dt array, dt row and column will be our distance. So what we are gonna do, for every iteration, like we create, this is our answer, means let assume this is our dt. So we create a distance matrix. So first we will pop this value, we will pop this value, we pop this value, and we create a visited, means we will create a visited, means we will mark in this that it is visited. So we will pop this value, we find the row, we find the column. Now we mark this row and column value to direction. Now value 0, its distance is 0. Now we will travel in the 4 direction. For every 4 direction, if its neighbor is 1 and it is not visited, one thing, value is 1 and not visited, 1 and not visited, then we will add it into the queue with its distance. So for current distance is this, so it does have any 1, so it does not have any 1. Now we remove this value, we go to this value, we'll remove row 0 1. And what is the distance 0? So distance is 0. Does it have any adjacent one? Yes, it have adjacent one, this. Now we will insert this. We will insert this. How we will insert? We will insert this row, insert this row, insert this column. We will inserting row, insert this column, and what is value? Now our value will be distance plus 1, means it takes one distance. So our value for current distance will be 1. Now it does not have any other elements, so this will pop. Now this will pop. So 0 to 0, it has distance 0. For 0 to 0, value is 0. This value will be pop. Now we have visited this 100 100, its value is 0, then value will be pop. After that 120 120 120 value is 0. Like for this element, I forgot, for this element when we pop this element, row is 1, column is 0, and our current value is 0. So does it have any node adjacent one? Yes, it has adjacent one, this, but this is already visited. It has only this node that is not visited, so we will add this into our queue. So we will add 2 0 and our distance is 1. After that this will pop and distance 0 will be added. Does it have any unvisited one? Yes, it has this unvisited one. It is already visited, so we will do not have to visit it again. It has only this unvisited, so we will add our 2, column is 2, and our distance is 1. Now this value is pop. When this value is pop, row is 1, column is 1, and distance 1 is 1. So row is 1, column is 1, distance is 1 is marked here. So this one, does this one have any consecutive adjacent one that is not visited? Yes, this has this one. So we will add this into the queue. So how this will be add? Its index is 1 and 1. And what is the distance? Current distance is 1. Means for this node current distance is 1. So next distance will be 2. Now we visited this 201, 201. We will, what is the distance? Distance is 1. So we will add 1, and does not have any neighbor 1. So we will return. After that, we will remove this from our queue. We will add this one distance. After that, we will remove this, and it has distance 2 2. So this is our output array, and we will return. We have to make 4 directional call. In previous video, if you check, we will create a two-dimensional direction array, and we will iterate. For every node we have also checked the boundary condition, means it should be in boundary, means values should be in boundary. It should not be outside the boundary. If outside the boundary, then we will return our value, means we will return null. And if it visited, then we will not visit it again and again. So this is our solution. Let's see the code. Like we create n and m to store the number of rows and columns. Then we create our output distance array, two-dimensional array of size n cross m. Then we create our boolean visited array of n cross m. Then we create a queue for BFS. What we will do means, if the value is 1, we will insert all the zeros to our queues for further processing. So we will create a new int ij and current distance in 0. Then we will mark it visited. Then what we will do? We will create a 4 direction array of two-dimensional. Then for every, means for every distance, we will make a normal BFS call, like a size minus minus is greater than 0. We will call the first value current index, and j means current row and column. And what is the distance? Distance will be d. So as we talk, we will initially set distance I and j of the d. Then we will make a 4-dimensional call. So if it satisfy the boundary condition, means row is greater than 0 and row is less than n, column is greater than 0 or equal to 0, column is less than m, and it is not visited, means you can also do add condition, means value is 1. But for this condition, we already make the value of zeros that are added to the true. So this will be work fine. So we will add row, column, and the distance plus 1, means for next step distance will be increases by 1, and we will mark it visited. After that we will return our distance array. So this is the working of the 0 1 matrix. So this is our problem solution. So complexity is big O of n cross m. We are creating an extra 4-dimensional array, means we are creating n cross m array plus 2-dimensional 4-value array. is 2 cross 2 array, and we are iterating in. So over all the time complexity is big O of n cross m. Thank you.